The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Hello everyone and welcome to the .NET Core podcast, the only podcast which is devoted to .NET Core, ASP.NET Core, EF Core, SignalR, and not forgetting the .NET Core community itself. I am your host, Jamie Caprogman-Taylor, and this is episode 5, ASP.NET Core. In this episode, I'm going to introduce ASP.NET, talk about what the core version is, and how it relates to .NET Framework. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. If you're new to the podcast, then you may not know about it or me, so I'm going to take a moment to tell you about both. I've been writing about .NET Core over at .NETCore.caprogman.com for almost 2 years at the time of recording this episode. I'm a developer from the .NET Core community who really digs on the core technologies and is a little bit evangelical about them. In fact, it's the reason why I started this podcast. For a fuller introduction to me, why I started the podcast, and what I'm hoping to achieve with it, you should check out episode 0. I'll leave a link in the show notes, so be sure to check your podcatcher of choice. The show notes for this episode will include a full transcription and some useful links, so don't forget to check them out too. In this episode, we'll talk a little about ASP.NET, what it's about, and what MVC, Razor, and Blazor are. We'll cover a little history and talk about what ASP.NET Core is and how you can use it in your applications. That's both .NET Framework and .NET Core, as we'll see. So let's talk about ASP.NET Core right after this. So what is ASP.NET? If you're old enough, then cast your mind back to the mid-90s. Sony's PlayStation had just come out and, unfortunately in my opinion, whooped the backside of the Sega Saturn. Toy Story, Pocahontas and GoldenEye were rocking the box office, and Alanis Morissette and Oasis had made a big splash with their debut albums. But this was the dark ages of the internet. The initial version of JavaScript had recently been released, and it was a long way from the version of JavaScript that we use today, and behaved differently in the different browsers. On the server, we had a choice between static sites or PHP-powered pages, both of which could use the new Common Gateway interface, but only small portions of each page could be dynamically created based on a subset of features available to web developers of the time. This was before Ajax, before Bootstrap, or whichever your front-end CSS framework of choice is, and even before jQuery. If you wanted to make your site work on Internet Explorer, you may have needed to include a few specific IE hacks. We kind of still have these to this day in the form of shims, but they are less widely used as the support for older browsers has been dropped. Pages were covered in marquees, animated GIFs, that's right, I pronounce it with a hard G, you may pronounce it with a soft G, I don't know, and it was incredibly important to have a guest book. Then along came blogs with their first comment wars, and Flash with its security issues, but my goodness was it ever fun to play those stupid games. I mean, use the internet for things that I needed to look up for school. Enter Scott Guthrie. Over the Christmas break of 1997, Scott Guthrie and fellow Microsoft engineer Mark Anders came up with a technology that they called XSP, which stood for Cross-Site Printing. It allowed IIS, that's Microsoft's Internet Information Service, which is a Microsoft-based web server and reverse proxy technology, to serve dynamic web pages. This technology would be rebranded as ASP, or Active Server Pages, before being made available to customers. Essentially, the innovation here was that a developer could write code which would intercept the incoming HTTP requests, use information found within it and any supporting cookies, and script the creation of HTML responses. What really set ASP apart was the use of the session and viewBag variables. To all of us doing modern web development, this is almost a given, but back then the ability to store data about all of the requests and responses for a given user at a given time, sometimes called a user journey, finally you could tailor pages to individual users and offer up truly dynamic content based on who that user was. To be fair, this was doable back in the dark ages of the web, but it came at a price. And that price was creating a lot of server-side pages or leveraging things like PHP. But now, it could all be scripted, using either VBScript, which is a variant of Visual Basic but used for scripting, JScript, which was essentially a subset of JavaScript created by Microsoft, or PerlScript, which is a variant of ActivePerl. Okay, so the syntax could be a little terse, but it was pretty similar to the bare-bones HTML that most web developers were writing at the time, especially since these were the days before things like Dreamweaver became popular. As we reached the millennium, version 3 of ASP was released, but Microsoft was betting big on something that they were cooking up. ASP.NET. In 2002, Microsoft released ASP.NET alongside the very first iteration of the .NET Framework. The fact that it was released alongside version 1 of .NET Framework was no accident. It used the very same common language runtime that applications built with the .NET Framework did. It also uses system.web.dll, which was included as part of the .NET Framework. Where ASP allowed you to build dynamic HTML pages, I'm really not doing a very good job of selling how big of a deal this was, or the amazing things that people could build with it, by the way. Essentially, ASP.NET would intercept the incoming requests and create an instance of what's called the HTTP context object for each of those requests. That object would then be passed to a pipeline that you created. Information within the HTTP context object contained the request URI, the query string, any cookies and related session data. This was a technology called web forms, which allowed you to create and use what were called server controls. These server controls could be embedded into a page with a shortcode, they would render HTML, and could be used to respond to user actions via postback messages. You can think of these as similar to components in modern web development. Web Forms was completely stateless, as is HTTP, so the ViewBag object was invented to partially alleviate this. This was essentially a dictionary which would allow you to store any value between those postbacks. However, it would be sent to and from the server as part of both the requests and the responses, which obviously could increase page load time. There was a technology called Web API which allowed you to write RESTful APIs in any of the .NET Framework languages. This no longer meant that you had to use CGI to generate responses in low-level code. You could leverage the .NET Framework's abstractions to do most of the hard work for you. SignalR, which will have an entire episode of its own, blew the doors off of what the web could do, and came much, much later. Essentially, SignalR sets up long polling, as well as a bunch of other stuff, so that you can have real-time bidirectional communication between a client and a server over the web. And then there was MVC. Model View Controller. If you've ever used Ruby on Rails, Django, or Java Spring frameworks, then MVC will be familiar to you. MVC is a fantastic abstraction for the web. It's not the only one. There's MVVM, Presenter Abstraction, and Model View Presenter too. There are a bunch of others, of course. It can be used on desktop or mobile as well, but you'll more than often find it being used on the web. MVC is split into three parts: Model, View, Controller. Essentially, the user interacts with a controller by sending an HTTP request. The controller creates a model, usually in the form of a POCO, that's a plain old C# object, which is then combined with a view to create an HTTP response for that request. The ASP.NET version of MVC is what's known as a thin client. This means that all the heavy lifting is done on the server side. The client, in this instance a browser, sends HTTP requests to the server, and the server creates and returns all of the content. Frameworks like Angular and Ember are the opposite of this, as these frameworks require some of the MVC components to be present on the client side. Most of the websites you've interacted with in the past 20 years will have probably been MVC based, unless they were static sites or single-page applications. ASP.NET Core. ASP.NET Core is the latest iteration of ASP.NET. Essentially, it's an open-source rebuild of ASP.NET with a focus on speed and cross-platform compatibility. At the time of recording, round 16 of the Tech Empower benchmarks have completed, These are a number of benchmarks designed to show off which web frameworks are the fastest, and ASP.NET Core is placed at 10th for plain text requests, which means it's able to serve 6,970,937 requests per second. Check the show notes for a link to that and for an image of the results from round 16. Although it's a core technology, that's my shorthand for .NET Core, ASP.NET Core, EF Core, Signaler, Blazor, those kinds of things, it can also be used with either .NET Core or .NET Framework. This is because it does away with the use of system.web.dll, which is what ASP.NET used and is supplied as part of Windows. Where ASP.NET uses system.web.dll with all of its Windows-based API hooks, ASP.NET Core uses a new web server called Kestrel. Kestrel was initially based on libuv. This was because of the cross-platform nature of libuv. However, with the release of ASP.NET Core 2.1, the ASP.NET Core team moved away from libuv and began offering Kestrel based on managed sockets. This was for a number of reasons, including, but not limited to, quote, broad platform support. Wherever managed sockets are supported, Kestrel should work. Doesn't require recompiling libuv to bring up a new OS. Helps drive improvement in the .NET sockets implementation, which benefits anyone else using managed sockets, unquote. For a link to where I got that quote from, see the show notes. Cast your mind back to episode 1 when I talked through a brief history of .NET. See the show notes for a link. I included in that episode the following quote from one of the early ASP.NET community stand-ups.
But this isn't just about making you able to develop ASP.NET on a Mac. We're looking beyond that.
Okay, so for now, it's
apps on Linux servers.
You had it from AppOps.
That's my goal. Is I want you to be able to host your ASP.NET app on a Linux server as easily as you can host it on a Windows server.
This would never have been possible using system.web.dll, but is completely possible using Kestrel. Because ASP.NET Core is built with the same modular nature as .NET Core, you are able to include just enough of it to run your application. This is a big change from ASP.NET, which needed to be included with your source code regardless of how much of it you were using. Another benefit to using ASP.NET Core over classic ASP.NET is that MVC and Web API have been combined into the same namespace. When using ASP.NET, MVC controllers needed to be separate from Web API controllers, whereas in ASP.NET Core, Web API, MVC, and Razor Pages, which we'll cover in a later episode, are essentially the same thing. Wrapping up. We've covered the basics of what ASP.NET Core is, how it relates to ASP, ASP.NET, and .NET Framework. We've talked through a brief history of ASP and a few of the other things that ASP.NET offered to web developers. We'll cover the types of applications you can create in ASP.NET Core in a later episode. One thing to remember about Kestrel, though, is that it's not battle ready. That means it hasn't been hardened against common internet attacks. As such, it's always recommended, at least at the time of recording this episode, that you still host your ASP.NET Core applications behind a, quote, proper reverse proxy and web server combo. Things like Nginx, IIS, or Apache come to mind. Anyway, that's going to do it for this episode. Hopefully you found it interesting. If you did, then let me know by sending me a tweet, twitter.com/.netcoreblog, or head over to the website, .netcore.show, and let me know what you think. Remember to check the show notes for a link to the full transcription of this episode and links to a bunch of related websites and resources. These are available at .netcore.show. And don't forget to spread the word. Leave me a rating or review on your podcatcher of choice, and to come back next time for more .NET Core goodness. I'll see you again real soon. See you later, folks.